All right, welcome everybody to last day of school. Make some quick announcements real fast. We got a ACM presentation today on game development at 6 o'clock. We've got the end of the year party next week at 9 a.m. And that one's not extra credit, but the thing tonight is. So that's the last extra credit opportunity of the semester, unless I squeeze in like one more meditation workshop. But with it being raining like this, we'll see if that happens. I might put up a thing where you can tell me if you're interested in it or not for one more point of extra credit, or maybe two. Not, if it's extra cold, it's two. So today we're going to be doing a little fun cooperative coding exercise together. We're going to be doing the Advent of Code for 2021. In the previous section, we did all the available Advent of Code 2022 stuff. So it's already been solved. So it'll be more fun for me to do the old ones that I have not solved yet. So this is something that since it's our last day, it's really important to kind of like repeat is that programmers typically for fun will code for fun, and that's not something you see like in a lot of industries, right? Like the your average pharmacist doesn't like deal drugs for fun, you know what I mean? Like when they're at home, they want to be away from like drug dealing, right? They want to just sit there and like watch Netflix or something. Generally speaking, it's not a hobby as well as a profession, right? But for programmers, we typically our hobbies oftentimes include coding for fun, and it's kind of weird because like if you're a zookeeper, like you don't keep a panda at home usually, although maybe you'd want to. So that sounds kind of fun. So artists often make things for fun. Yeah, that's true. That's true. Walter White does do chemistry at home. Okay, yeah, fair enough. But yeah, we're a little weird, I guess. And so Advent of Code is one of many things. I've made an announcement on Canvas that has all sorts of different ways for you to practice. And it's really even if this isn't fun for you, and it's actually fun for me. I actually really enjoy like having these fun little problems and solving them and seeing how quickly I can do it and how few lines of code I can do it. Like each of the Advent of Code things here were about 15 to 16 lines of code, and there's two parts to each one, and the second part changes the first part. And so I was very happy for day two. It's rock paper scissors, and for the second half of day two, I only had to change one line of code and add one line of code. So even though it was a kind of a different ish, problem to solve, it was all like it's kind of fun to see like how few changes you can make to do something, because in computer science, and this is something I've talked about before, but it's something I'm really passionate about. Most of the time when you're doing computer science, you're not writing new code. You maintain old code, and almost no college classes will give you that experience of taking a product through multiple revisions and multiple iterations and redirects and things like that. One of my favorite classes at UC San Diego was a software engineering. I don't know if I'd call it a projects class exactly, but we can call it a projects class run by a guy named Bill Griswold, who's a really fantastic individual. And what we would do is every week we would take the same program. So like we would start with a program in week one. He's like, I don't remember actually what the project was, but I'll just give you an example. Code blackjack. Okay, and by that point we're either in upper division or grad school. I don't remember which one I took. I think both with him maybe. And so by that point, okay, fine, we'll code blackjack. And then the next week, it's like, all right, take your existing blackjack implementation and make it so that it's out of 30 instead of out of 21, or make it out of 5 or 10. Like how does that change your code, right? So yeah, sure, we could change it, but like you had to write a report, and the thing you had to write on was like, how much of your code did change and why did you have to change it? And if you knew that it was going to be this way from the beginning, how could you have made it so that your code would have been more flexible and more easily modifiable? And there's always going to be lines of code difference, but like sometimes you have to end up doing like a full rewrite. Like if you always assume that like the decks of cards are going to have like hearts and spades and clubs and diamonds in them, and they turn into cups and moons and stars and whatever, like the old school medieval decks of cards. Like if you've done your code right, you only have to change it in one place. This is what we talked about in the last time, right? But if you just sort of like hard coded in all sorts of different places, like parts, then you've got to rip out all of that code and refactor it, and maybe make it so it'll work with any like four names for the suits and things like that. And then maybe the next week it's like, all right, now turn your thing into poker, and you're like, oh dang, shoot, this whole thing was written with blackjack in mind, and poker, wow, yeah. But the whole point was like, did you have a good card class? Did you have a good deck class, right? Because some of the mechanics of blackjack and poker um, come from have like in blackjack, if you play single deck blackjack, it actually really matters that you actually keep track of which card's been played and not, because the probability of winning goes up and down based on how many cards are remaining. And so maybe you could like you had a good card class and good deck class for blackjack, and then you could repurpose that for poker. And then maybe they make you change it so it's not a 52 deck of cards, but like a pinnacle deck or something like that. And each time your thing mutates, every time it changes, you have to go in and start with your old code and update to the new code and look at how many lines changed, and were these changes all in one place, or are they scattered across all of your code. And you did that every week. Every week you would come out with a new iteration of your code. And it was a fascinating class. It was like one of my favorite software engineering classes that I've ever taken, because it really makes you think about up front, like, okay, what's he going to do to us next? Like what's coming, what change is going to happen. And so some of my friends would over engineer changes, right? They would make, all right, so I'm making a general purpose card game, class, and then you can instance it with like poker or blackjack or pinochle, and they would write like thousands of lines of code, whereas my code would be like this big, and it's interesting. It's like, well, okay, sure, they had to refactor less code afterwards, but total amount of time spent writing it, me winner, so I don't know, like it's really something to think about when you're doing development. Okay. Patch notes, not patch notes, but like the patch itself, right? So like when you have version 1 of a game, you make version 2 of the game, the patch is like the difference between part 1 and part 2. And ideally you want to have the patches as small as possible for the same feature changes, right? And every person's project was different. Everyone engineered it a different way. And so everybody's patches were different too. And it was really interesting to see like how people went about building and architecting software. And that's something that you usually just don't get a chance to do in a class. Usually that's something that you are surprised by when you enter the real world, and you have to design a product that's future proof. Ooh, that's a tough one. I can tell you about Teradata and their pivot to the cloud, and oh man, they had all of their programs were written in assembly for like these specific CPUs, and then their CEO is like, we're going to go into the cloud, and just an absolute train wreck disaster of epic proportions. Okay, so let's do some advent of code. I'm going to go log in real fast here. And we will switch the year to 2021. Okay. So we're gonna do this together. And will this be on the final? No, there's no final in the class. Just make sure that you get all of your competency exams done. Make sure you get any remaining work done. There's probably not much left. There's no Zybooks left. Yeah, I mean, if you guys want to peace out, that's fine. We're just gonna be doing this for fun, little programming practice. Like I said, this is what programmers do for fun. Like we'll solve little coding challenges and things like that, and it's fun for us. And so on the announcements, I've posted some other places where you can go and get experience, and also a couple fun things as well. So there's a guy by the name of Zach who makes a thing called Zachtronics, a company called Zachtronics, and Zachtronics has come out with a number of games over the years that are actually programming games, like TIS 100. Highly recommend TIS 100 to everybody who's interested in programming. It is a massive 48 megabyte install. 48 megs, man, that's like 48 floppy disks. It's crazy. Okay. But this is a game in which you write programs to solve the puzzles, and there's like a story and a conspiracy theory and stuff like that. It's kind of fun. It's really neat. Okay. Anyway, so yeah, follow the instructions. Make sure you back up your software. Everything you have on the server is going to get wiped on January 8th. So make sure Everything's been backed up by then. And yeah, over break, you should do some coding. Like do the hour of code. It's coming up, I think, this week. Do the advent of code. Do HackerRank, that kind of stuff. You got to keep in practice, right? Everybody who programs needs to kind of keep their skills up. And I hope all of you take 41 with me too. So 40 and 41 are like two halves to a sandwich. If all you take is 40, not 41, because you're like, oh, I'm not a computer science major, I don't need it. You need it because your major, if your major requires you to take one semester of computer science, you actually have to take two. You will be horribly surprised when you become a senior in physics and you realize it's all programming. So I did make a lot of money over the years, though, working for departments that should have produced people that knew programming but didn't, because they only had one semester. So yeah, all right, here we go. Sonar sweep. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights, because of course it is, and even has an experimental antenna that should be able to track the keys if you can boost its signal high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. Oh yeah, this is why it's called an advent of code. It's like an advent calendar. You open. Have you ever seen those things where you like open the little window and like get a chocolate every day? Those are called advent calendars. So every day they release a new coding challenges. Collect stars by solving puzzles. 2 puzzles will be made available in each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, 199, 200, 208, 210, 200, 207, 240, 269, 260, 263. This report indicates scanning outwards for the submarine. The sonar has found depths of 199, 200, 208, and so on. The first order of business is to figure out how quickly the depth increases, so you know what you're dealing with. You never know if the keys will get carried into a deeper ocean by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There's no measurement before the first measurement. In the example above, the changes are increase, 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 decrease, increase, 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 decrease, increase. There's 7 measurements that are larger than the previous one. How many measurements are larger than the previous one? Okay, this is going to be pretty easy. All right, so we will get the puzzle input here. And we will save this to disk. And we will use win SCP over here. Log in. Desktop input, and we're going to put this into input. Okay. And so now if I go onto the server, I'm going to leave that number like kind of peeking out on the side over there so that we can kind of look at it and kind of see what kind of stuff we're doing. Okay, so move main.cc to advent of code day22.cc. Okay, so we will start from scratch. So we need to count how many times this input here went up. Okay, so Gurpreet, what do we do? AFK. All right. Romero or Dermer? What do we do first? We got all these numbers here. What's our first step? How do we approach this? IF stream. Very good. And one of the reasons why I've given so many IF stream assignments this semester is because in years past, I do like 1. And then by the end of the semester, people had forgotten it, right? Like one of the ways you memorize things is by doing it over and over again, right? And so that's why I did data science with you guys and some other things that involved like Pokemon that read from a file, Bank of Keith. Because if you do it enough times, it'll stick. Okay, so we are opening the file. And maybe Romero, you here? Lindsay? wonder if I put people in the AFK section. Nope, they're back. Okay. All right. Let's see. Hawkman. What should I do? I got this file here. What should I do? Should I vet it? Just assume that it's there. What do you think? Everybody. Apparently everyone's AFK or not wanting to talk. What should I do next? Make sure it's open. If not, ends. No, I'm not going to do it. While true. So why am I not doing it? Well, because here's the thing about all these coding competitions. Most professors, I don't know about most, but it's very common for people to get used to having your input always be good. And so there's a very bad habit by a very large number of people where they just don't vet their code and they don't see if the file was open. They don't see if the data was in the right form. They don't check for errors. They don't check to see if there's a squirrel where there should be an integer, and they're just not used to it. And so most of the time when you're dealing with coding competitions like this, yeah, you don't check for any of that stuff. So it makes me feel like a little dirty, you know, that we're just not checking to see if it opened. We're not checking to see if there's any bad input in there. But at the same time, we're doing a coding competition, and so speed and lines of code matter. And so we're just going to assume that it works, which is, I feel very guilty about saying that. Okay. So yeah, no, not ends. We're just going to assume that it works. I put it there, right? Okay. So let's just maybe just start off by just dumping the file to the screen. Just make sure that we can read it. You know what I mean? So these are all integers or something. So we'll just do int x equals read from the file. Cout x, and maybe like if not ends break. So if we get to the end of the file, do a little for loop. This will simply tell us if we are going in the right direction. A pipe through more. 159, 158, 174. Good. And let's cat input. Last one is 8568. 8568. Okay. Cool. We are successfully reading the file. Now, do we need to put this into a vector, or should we be able to count how many times the increased goes up without a vector? What do you think? Do we need a vector? Counter? Just count how many times it goes up? You don't need one? Yeah, I don't think I need one either. While loop? Sure. Okay, maybe we just use the same while loop even, all right? We don't need a separate while loop and a vector. We can just process it as it goes along, right? And so in computer science, oftentimes we call these things free algorithms, like there's zero cost algorithms. Because in order to do anything with the data, you have to open the file and read it from disk, which is expensive. And so doing something minimal, like just seeing if it increased from the previous one, is almost no cost at all. So the actual algorithm itself is basically free because you're gonna have to touch all the data on disk. So we just do the loop at the same time. It's essentially order n, but it's really very close to a zero cost. Okay, so we got a while loop. What should I do? So int increased equals 0. How do I check to see if the current number that I read is bigger than the last number I read? Termp. Okay. Int termp equals int max. Is that a thing? Nope. Max int. Is that a thing? Nope. How about that? Warning. How about just 999? The first thing in our file is 159. Good enough. Okay. Got it. All right, now what? What do we do next? And there it is. It's in C limits. So that is the maximum value that can be held in an integer. Make it conditional within the loop to check. Okay. So if this value, if the value read is greater than the, let's just call this the last one. Okay. If the current guy is greater than the last one, then increased goes up by 1. And that's the algorithm, right? And that's going to be lowercase. Okay. And then we'll just output the value and we'll output increased. And I think we're probably pretty good. Main.cc. None of these are increased. What is going on here? Oh, right. Last is equal to x. There we go. Okay, so every time it goes up, then, and that's why you always debug your code, right? You might think that it works, but until you've tested it, like, no confidence, like, whatsoever, you know? And that's why I see out all the things. And a simple thing like this, I see out all the things. Bigger things, I might be using a debugger, might be logging into a file. But yeah, just, you know, just when you're good at programming, you just spot a bug like that and be like, boom, done, up, missing, up, done, right? It's part of the process of getting good at things. So let's see here. That went up and then it incremented. Let's see if we can find one where it didn't go up. Okay, 40. Okay, good. I think we're good. I think that's actually probably the answer right there, 1583. So let's go over to Advent of Code. 1583. Paste, submit, and that's it. Boom. Easy peasy. All right. So that was part 1 of Advent of Code. That's it. That was the whole thing. So, see, crazy. Okay. So considering every single measurement isn't as useful as you expected, there's just too much noise. Okay, here we go. All right. Too much noise in the data. So we're going to do a 3 measurement sliding window. Again, considering the above examples. AB, ABC, BCD, ECD, EFD, EFG. Okay. Start by comparing the first and second 3 measurement windows. Measurements in the first window are marked A. The sum is 199 plus 200 plus 208 equals 607. Second window is marked B, 200, 208, 210. Sum of measurements and okay. So what we're going to be doing is we're going to be adding 3 numbers together. We're essentially averaging them, but we're not actually divided by 3. Okay, so stop when there aren't enough measurements left to create a new 3 measurement sum. So it feels to me like maybe we need a vector now. We could probably do it without, but I think having a vector is nice so that we know where to stop. You know what I mean? Like we can stop 2 away from the bottom of it, right? It's like 260 and 263 there aren't going to be averaged together, right? On their own. What do you guys think? Should we put it into a vector? We can probably do it without. Maybe if an error occurs, we break. Maybe we read the first 2. We can probably do it without a vector. I don't know. What do you guys feel like? Read until the end of the file. We got that code already. We're gonna just need to have like a sliding window. of values. You like vectors? Add another vector. Yeah. 2, 3. You like vectors? Okay. All right. Okay. So make advent 2021. Copy main.cc. Advent 2021 as day 11.cc. So I think our code here is already pretty close. Bring what we need. So this is what I was talking about with the software engineering thing, right? What is the fewest lines of code change we can make here that would still allow us to solve the thing, right? Obviously, we're going to need to do some sort of like adding together of 3 numbers. We're going to have to like read and maybe replace numbers depending on how we do this. What do you think? What's the smallest change we can make to this code so that rather than comparing, one number to one number, we're comparing the sum of 3 numbers to the sum of the next 3 numbers? Dead silence. We could use a vector. It's doable. I can think of at least 2 different ways we can do this without a vector. But maybe a vector is easier. I don't know. Got a bunch of CSI 40 students here, guys. Come on, come up with some ideas. How do we do this? You want to just start by reading it into a vector? Okay. Vector events named vec, and rather than okay, so we are going to read this, and rather than doing this code here, I split these into 2 different loops. Are you cool? Who are you? What are you doing here? All right. I don't know what's going on. Okay, so rather than doing that kind of stuff, we will just put it into a vector. So we'll say vector dot push back x. Okay, and so we'll do a 1-line file read. Not quite as nice as Python's 1-line file read, but still pretty good due to the power of the read lib, brought to you by yours truly. And then we'll pop the duplicate because this construct here will remember when an error occurs, you have to read 1 off the edge for it to go false, and so we'll end up with an extra element in the vector. So it's, like I said, not as nice as Python. So it's better than normal. So that's a 1-line file read. And then maybe we just do like a little one of these things, right? Like a little range-based for loop, just see out the thing, just see if we're kind of like doing it right. Okay, so it worked. Puzzle input. Just check to make sure top's the same. 159, 174. Cool. All right. So the vector read worked successfully. So we could do another vector that is the floating window computation. I think 5D chess. What do you guys think? What do we do here? We need to add together the first 3 elements, then 2, 3, and 4, then 3, 4, and 5. If we wanted to do this like just not super optimally, we can make a second vector and just sum 3 at a time out of the first one into the second one. I can think of better ways of doing it, but that's kind of like an obvious approach. Come on, toss me ideas here. You guys are all programmers now. You guys understand the thing? Like, this is our input, right? And so we need to add together 1, 2, and 3, like that, to get a sum. And then we add together 2, 3, and 4 to get a sum. And then we're going to count how many times the sums of 1, 2, and 3 to 2, 3, and 4 to 3, 4, and 5, 4, 5, and 6 go up or down. We need the first entries first, then we can subtract the first one, add the next entry to compare. Okay. Okay. So you have a running total where we like subtract out the 1, 3 behind us, and then add in the new one to have an ongoing running total. Maybe like when another comparison for when the value is less than negative. Worded that poorly. Maybe when another comparison. What about a for each loop through the vector and added each entry to our total if the proper requirements were met? We could actually probably just do this directly, honestly. Like, I'll just do this. For int I equals 0, I is less than vector dot size minus 2, I plus plus. Why the minus 2? The last element we do is actually going to be 2 to the left of the actual end of the vector. Yeah, end of file, or the end of vector, right? Because we're going to be grabbing the current guy and the guy to his right and the guy to his right. And so if we're going to be grabbing people 2 to the right, then you have to do this and stop 2 from the left. Okay. It's the kind of thing you learn through long exposure to segfaults. Okay, so we can have current guy, and so last actually could work with this. Okay. Right. So. Okay, so int sum is equal to vec square bracket I plus vec square bracket I plus 1 plus vec square bracket I plus 2. And if sum is greater than last, increased plus plus, and then last is equal to sum. That's it. It's basically the same code as before, right? But like you could see from the assignment, like at some place in there, you would need to add 3 numbers together, right? It's very close to the same code as before, except we read it into a vector. And the reason for that is because you need to stop prior to the end, right? So when the end of file kind of hits you suddenly, then you're like, oh, dang, can't do that. So this, like I said, you could probably do this as you go along, and when you hit an EOF, handle it. But this way, it's fine, right? So you read it into a vector, and then you stop 2 from the end of the vector, so you know where to stop. And then you grab your current value, the next guy, you add them together. If it's greater than the previous guy, it's an up, and then you just save it. So that should do it. Probably should see out some things. I don't know. Let's see here. See out some last. Increased. All right, that's max out, right? That one doesn't count. Okay. So the first three guys here, 300, 425. It's now the first three are those three. Sorry. Okay, so 159 plus 158 plus 174, 491. Good. But that one doesn't count for the increase because that's why I was setting integer max as the previous. So it doesn't count one on the first guy. And then for the next three, they're bigger, 380, 485 change. 384. Okay, yeah. And so the new sum is bigger than the old sum, right? Because the 196 is replacing the 159. And then the next one, the 197, is replacing the 198. And so, yeah, like you're saying, like you could probably just delete the old value out and add the new value in to get the new sum, and just do that as a sliding computation as you go along. This approach, though, I don't know, is easy to write. Like I said, there's a lot of different ways of solving these things. So, I don't know, let's give it a shot. Let's see if that's it. Probably won't be, but yeah, can't hurt. No, that's right. Okay, cool, nice. It's always a good feeling when your code works right the first time. You know, you can't get too spoiled by that though. You can't get too confident, too cocky that your code's always going to work right the first time. That's the code. Okay, so copy. Let's move main.cc into Advent 2021 into day 1 part 2. All right. What do you think? Is this fun for you, or yeah? This gold stars raise up the high horse. Yes, it was only day 1, so yeah. It's just kind of a fun little coding experiment. I'm kind of hoping also that if you guys kind of see how I code, we'll get some valuable lessons or something. I was thinking about doing like a floating window and then like rotating through which one of the three I'm reading into, but I don't know. Sometimes I just want to code things quickly and get it done. All right. If you're with Google's Code Jams, yeah, Code Jams are cool. Hackathons are cool. Like anything that gets you practice coding and practice doing stuff is good. Okay. Definitely be going through semesters. Yeah, and nothing here is like stuff you can't do, right? It's all, pretty straightforward stuff. So, okay, it does seem like the submarine can take a series of commands like forward 1, down 2, or up 3. Forward X increases your horizontal position by X units. Down decreases the depth. Up decreases the depth. Okay, increase. So down increases, up decreases. Got it. Okay. Note that since you're on a submarine, down and up affect your depth, and so they have the opposite. Yeah, okay. Yeah, exactly. The opposite result of what you might expect. The submarine seems to have a planned course, your puzzle input. So you should probably figure out where it's going. For example, forward 5, down 5, forward 8, up 3, down 8, forward 2. Horizontal position, depth both start at 0. Good to know. Steps above would end up with forward at 15, I think, and down at 10. That's all right. Horizontal 15, depth of 10. Multiplying them together produces 150. That is not how Euclidean geometry works. I guess, yeah. I guess we're moving in a straight line down, then a straight line east and down. Okay. But, okay. But if we're caring about the total distance traveled, it should include both the up and the down, right? For a mileage counter. But if you're trying to figure out how far away you are from the start, then we should be doing the Pythagorean theorem instead of Manhattan distance, which is what this is. Do you guys know the term Manhattan distance? Messick, Otal, McCrelly? Do you guys know what Manhattan distance is? No? Yeah? No? So when you travel in New York, it's all in city blocks, right? So you can't actually take a diagonal. Like if you have to go 1 block east and 1 block north, there's no diagonal there to make the distance 1.4, right? Instead, the distance from this point to this point is 2, because you have to travel 1 block east, 1 block north. So that's what they're doing here. They're essentially doing Manhattan distance instead of Pythagorean distances, which I don't know. Maybe part two. Maybe part two will be computing the actual distance. But here we go. Okay, so copy. You know, I don't even need to win SCP. I'm just going to copy paste it over and move input to Advent of Code 2021 input 1. Okay, and move input 2 to Advent of Code right here. All right, so Vim input 2. Why not? Okay, there we go. So there is our code. Now we need to make a new program. Okay, so we're going to be reading in, I'm just going to leave it over here. So we're going to be reading in getLine. Again, we don't have to worry about the file not existing because I just put it there. We don't have to worry about, I mean, we should be. Again, I feel very guilty for saying this, but okay, ifstream ends input 2. And because this code only exists long enough to give us an answer, and then we can bin it, you know. I actually deleted the part 1 after day 1 on the first one I did in class, and then I was like, part 2 uses that, huh? Oops. Fortunately, I had posted the answer and was able to copy and paste it back on that. Okay, so we're going to open the file, and then let's do what we did before, while true. And so I guess we can do it like this. String s is equal to read from the file, and integer x is equal to read from the file, and we'll see out s followed by x. And if an error occurs, we're probably at the end. Just break. Okay. Hit it, pipe through more. So forward 9, down 3, down 8, forward 2, up 3, forward 5. Looks good to me. Run it again. At the very bottom of the file is up 3, forward 2, forward 7. Up 3, forward 2, forward 7. Up 3, forward 2, forward 7. Okay, cool. So you always want to check the first couple lines, last couple lines, because a lot of times, like, the last line will be repeated if you forget to break properly. So it's always important to check the very last part of the file, the very first part of the file, to make sure you're getting everything correctly. Make it a pair. We could make it a pair. Okay. But nah. Okay. My chair keeps sinking on me. Okay. So what do we do? So we're supposed to add up, at the end of the day, we're supposed to add up how far we traveled horizontally with how far we net traveled vertically. We multiply them together. Okay. So how do I do that? What should I do? I need to make a couple variables maybe. What should I do? Would I use a map for this? No. This can be done entirely with just 2 integers. Okay. Use if statements for the string. Good. All right. So we will say if s doubles equal forward. So if s is forward, then that will add to our x location, I guess. So x plus equals x. Oh, dang it. We already have an x. And no. Why is variable naming so hard? Movement. So if we're moving forward, s plus equals movement. Else if s double equals down, then you have to wonder what happens if the submarine goes up at the beginning. Right here at the surface, you try going up. Is that gonna y plus equals movement? Otherwise, we'll assume that it is up. Probably should do it better with like a error checking and stuff like that. But yeah, why not? I'll do it properly. If s still equals up, then y, the depth is decreased by the movement. And otherwise, exit 42. All right. See out all the things. See out all the things. So do you guys see this process? Like a lot of times students will just run their code, movement. Totally, dude. Like experienced people like will make mistakes. It's just a matter of detecting the errors quickly and fixing them. So this, as this thing runs, I'll just be able to see what the accumulated X and Y is, and I can just look at it and see if I'm kind of doing it right. Maybe I misspelled forward or down or something, right? So I'm just going to run it through more. More shows one page of text at a time. So forward 9, we are 9 ahead. Down 3, we're at a depth of 3. Down 8, we're at a depth of 11. Forward 2, we are now at 11. Up 3, so the depth decreases. Forward 5, we're at 16. Up 8, we're back at the surface. Again, it's an open question. Can the submarine fly or not? But again, on these sorts of input testers, they don't. You see it never went negative. So they don't throw curveballs like that on you. Okay, so it looks like it's fine. No errors were occurred, so that's cool. And then we have to just output answer x times y, I think, Manhattan distance or something. Yep. Answer is this. All right, let's give it a shot. See if that's the answer. That's the right answer. Boom. All right. Based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover the process is actually slightly more complicated. In addition to horizontal position and depth, you'll need to track a third value, aim, which also starts at 0. The commands also mean something entirely different than you first thought. Down X increases your aim. Okay. Up X decreases your aim. What does aim mean? Okay. Forward increases your depth by your aim. Oh, I see. Okay. Yeah, wait, what's aim? Right. I told you guys, right? Like this is actually, I actually really like this because you write a solution and then you have to mutate it. And that's actually a really good exercise to do for programmers. So you just solved it with forward X, down, whatever. Now it's going to have the exact same input file, but they mean something different. And so, like in the previous class, we did rock paper scissors, and then in the second half, the commands given by the second person change, like what it means. Versus in the first one, it means either rock, paper, or scissors, or whatever. In the second one, it means whether or not you're going to win, lose, or draw. And so I was able to adjust it so that it was only a one-line change. One line modified and then one line added to switch between the two versions, which I'm kind of proud of. Okay, so this one is your aim. Down X increases your aim, up X decreases your aim. So if you have an aim of, let's say, 2, and you travel 10 ahead, you move 20 down. So this is your slope, basically. So aim is your slope. So down and up adjust your slope, sort of. Okay, since you're on a submarine, down and up do the opposite of what you may expect. Down means aiming in the positive direction. Yes. Okay, so forward 5 adds 5 to your horizontal position. 5 because you aim 0. Change. Down 5 adds 5 to your aim, resulting in a value of 5. Forward 8 adds 8 to your horizontal, a total of 13. Because your aim is 5, you are now at 40, right? So you have a slope of 5 essentially. So you travel 8 to the right, you travel 40 down. Up 3 and decreases your aim by 3, resulting in a value of 2. Down 8 adds 8, resulting in a value of 10. Forward 2. So if you have a slope of 10, when you move forward 2, it moves down 20. and that accumulates into it. So, okay, so we're going to have aim and depth held separately. Forward should be the same. Calculate the horizontal position and depth you would have after the fall, after falling the high course. What would you get? You multiply your horizontal by your funnel width. Okay. Okay. Cool. So same input, but different meaning. All right. Copy main.cc into advent of code 2021 day 2 part 1. Okay. So we're still going to open the same file. Our x and y position is going to be the same. But we need to track aim now. And aim is probably an integer. It has to be an integer. Aim equals 0. I think it defaults to 0, right? Starts at 0. Good. Okay. Okay. So instead of our depth changing directly, our depth only changes when we move forward. So which lines of code here need to change? See out all the things. Every time we read a line, we'll see what we're doing. Okay. What lines need to change here? Do you guys understand what's going on? Like before, we would go down, we'd go up, and move right. So we're basically just moving on a Cartesian plane before. On this one, the down and up instructions adjust this slope. And then when you move forward, that's the only time you actually go down. Okay. So forward with 10. Good. Yeah. So the forward command needs to be the only place that depth increases, right? So these guys are going to not exist anymore. So x plus equals movement, and then y is going to change with movement times aim. Because the aim is 5 and our movement is 10, we move 50 down. So what do we do with the down and the up now? We need to refactor this too. What goes in those two lines where I've got comments? Yeah, it's going to become aim now. So when we go down, aim goes up. We go up, aim goes down. Okay, seems fine. All right, let's try it. Okay, so we say forward 9. We're now at 9 horizontal, 0 vertical. Down 3, so good. It doesn't move down now. Instead, the aim points at a slope of 3 down. Down 8, it's now pointing at a slope of 11 down. Then we move forward 2, it moves 2 horizontally and 22 down. Good. Up 3, so the aim decreases. Forward 5, aim is now 8, so that's 40 down. Good. And 8 times 5 is 40, and then 11 plus 5 is 16. Okay. Up 8, so aim is now 0. Down 2, down 5 is now 7. Up 7 is now 0. Down 9 is now 9. Forward 4, so it moves 9 times 4, or 36 downwards, which seems correct to me. So this is looking good to me. So I'm going to run it, and the answer is some big number. Ooh, is that going to overflow? We're getting into like overflow territory, so I am just out of an abundance of caution going to make this a int 64 type, not 65 type, 64 type. Thank you very much. Just in case, I'm going to do 64-bit math instead. Okay, we did not overflow. It would have been very tricky of them to do that because again, they typically don't have any errors like that in here. Let's see if we're gonna get it right for the 6th time in a row. Yeah, boy. That's how we do it. Okay. So first time correct, 6 times in a row. It's a 6-peat. Actually, no. We did 4 in the previous class. We did 4 in this one. So that's 8 times in a row. 100%. All right. Not like it was perfect along the way, right? Like, make mistakes and stuff like that. It happens. It really does. Like, maybe somebody other is watching this stream and like, oh, I wouldn't have made that mistake. I never forget a semicolon. Okay, cool. Whatever. It doesn't stop me. It's like, I forgot a semicolon. It takes a split second to go back and put it in. Whatever. Okay. It's 3:40. Let's see. We got technically like another hour left. Do you guys want to do more of this? Do you want to hear a 1-hour lecture on security and hacking? Like, what do you feel like? Aaron, you're on the class. You don't get to vote, unfortunately. Go more of this? Okay. I'm happy doing more of this. Like I haven't done these events before. Betancourt. Are you doing day 3? I could do day 3. Yeah. On the 2022 one, yeah, it drops at 9, so I'll probably get that done all the way. We're gonna do the entire 25 days hour of code. The next hour. Blastoise. I might have a Squirtle. No, I have a Squirrel. Okay, that's not a Squirtle, but it's a Squirrel. There you go. Okay. How do I not have a Squirtle sticker? I'll give you a Sonic one. There you go. There you go. Super determined. Here we go. I might head out if we're between stuff. Yeah, you can take off. It's fine. You're not gonna fit in. I think we've covered everything important. So let me just stop here. Then I will keep doing Advent of Code if you guys want to see it. But I want to thank you guys all for a great semester. You've been wonderful. I've really liked the energy you've had on Discord, and a lot of you guys have been helping each other out on Discord. It's nice to see students like working together and like really sharing like how how do you make a vector in Java and things like that. It's part of the community of being a computer scientist. And all too often computer science become these like horrible, toxic, like jerk faces. But you guys have been great. So if you're gonna log off now, I just want to say thank you. And again, please thank Mincarelli and Aaron's here, and Betancourt is here for all of their time they spent helping you guys this semester. Because Betancourt isn't even your TA, right? Like he's hired by a completely different college. He's just helping you guys for fun because he likes helping you guys, And Aaron isn't even like employed by our district. Aaron is at San Jose State working on an internship with Berkeley, and is still taking the time to help you guys. So it's one of the greatest things about I think about our college is just how helpful people are. Like you guys know, you can contact me at 12:30 at night. And like I was helping people with Java Rainfall for probably 5 or 6 hours yesterday. But I can't do it by myself. I'm just one person. I think one of the reasons why our program here is so good is because we've got just a really great group of students who've graduated already, who come back and help the next generation. And so maybe that could be you guys. Maybe next year you guys and don't leave the Discord. Like stay on. Like maybe next year after you've taken 40 and 41, the next group of CSI 40 students shows up, and you get the tutor tag on you. Your name turns green on Discord, and you offer some help to the new people. What is this Vim thing? How do I exit? How do I compile? That kind of stuff. And it really is a good way of learning too. Like, even though you're helping other people, like that process of teaching people and looking at their code and debugging their code and working out problems and things like that. It's really good for improving your knowledge as well. So if you want, you can apply to the Tutorial Center. I highly recommend it. Becoming a tutor is a great way of learning. But even if you don't want to make it official or anything like that, just hang out on Discord like all these guys do, and just help the next generation when it's their turn, and give back, pay it forward. I don't know, like whatever those cheesy phrases are, but honestly, like it is I think a really neat community that we got going here, and I'd be very happy to see you guys stay on for years. Some of our tutors have been helping out for years, so it'd be really cool. Embedded tutor for CSI right here. FCC or CCC, we hired one of Kearney's 40 students. Yeah. So. It ain't easy being cheesy. Yeah, that is a cheesy phrase. Okay, so if you guys want to head off, I won't stop you. But if you guys want to stay here and see some more Advent Calendar 2021 Advent Code solutions, I will go through the end of the semester, which is coming up in 4 to 5 minutes. So thanks, everyone. You don't need a laptop. All the computers there have Unreal Engine installed. All right, day 2, return to the Advent Calendar. And let's go to day 3. Yeah, thank you. Okay, the submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers, which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. So that sounds suspiciously similar to what we just did. Whatever, okay. Each bit can be determined by finding the most... Oh, interesting. Okay. Oh, interesting. All right. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. So for example, given the following diagnostic report, 010, 1111, 10110, considering only the first bit of each number, there are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma bit is 1. Okay, all right. The second most common bit is 0. So the second bit, the most common second bit is 0. So the second bit is 0. The most common third, fourth, and fifth are 1, 1, 0. So the gamma rate is 10110 or 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, we use the least common bit. Okay, so the epsilon rate is 10110 or 9 in decimal. Multiplying the gamma rate by the epsilon rate produces a power consumption of 198. Use the binary numbers in your diagnostic report to calculate the gamma rate and the epsilon rate and multiply them together. Be sure you represent your decimal, not binary. Okay, that was interesting. Okay, all right. Got an input file. Good input file here. All right. How many bits is this? 12, it looks like. Okay, so you can see the binary numbers over there. What approach, zoom these in maybe a little bit for you, so you can observe them and admire them. What's the first thing we should do? We got 4 students left. Everyone else bailed because they are not true computer science students, clearly. 2 TAs, no, 3 TAs, sorry, 3 TAs and 3 students. So everyone else just DC'd.
Always love solving them problems.
If only they knew that I'm going over the final.
Honestly, quite incredible.
Live gaming channel reaction. All right. I'm going to unmute everybody. Minkrelli is not muted anymore. Nobody's muted. Nobody's muted. So yeah, just pipe up. Unmute yourselves. What should we do? First thing, IF stream. Yeah, cool.
You know what you should do?
What's
We should
up?
do this in C.
Hell no. Hell no. I want my code to be like easy to
Readable.
write. Readable, easy to write. Like it's none of this would be bad.
You could always write a read library from C and then just use that to help you out.
None of this would be.
I still have it.
Oh, you still have it. That's hilarious.
All right, let's see.
Let's open it. Let's do this. Let's do the thing. I'm not going to ask you guys. I'm just going to do this. We'll do a little. We can't read this as an integer, right? Because the leading 0 will get dropped. So we need to read this as a string. So we're going to do like S.
Wait, wouldn't this technically be a binary file?
It is not a binary file. It's an ASCII file. Each one of these characters is going to be like ASCII, like what was it, like
values
40 or whatever it is.
Yeah, like you're working with ASCII values. Like I think A is 95 or something.
Yeah.
So you're gonna be doing. Yeah.
It's 48 or 49. These are not binary. These are ASCII binary.
Yeah.
Yeah. Okay. So string S is equal to readline from the file. So that'll give us that. And if we have hit the end of file, we will just break. Otherwise, let's see it out. See if we can read it properly. Okay. And type it through less. Make sure the top looks good. 01, 00, 11, 010, 11, okay, looks fine. Shift to the bottom. We got 4 ones. Okay, looks pretty good to me. All right, solid. Okay, so our IO stream is streaming IOs properly. Don't need you maybe anymore. Okay, so So this is a string, and so there's it occurs to me that like we actually don't need to use like binary. Like when I first read this, I thought, okay, we're gonna have to use like bitwise and, right, or bitwise or bitwise. You know what I mean? Like using, grabbing individual, or I was thinking about using maybe bit set, but now that it occurs to me, like I don't think we actually need to do any of that.
You can probably just treat it as a Boolean value, if anything.
No, we can treat it as a string. We can actually just say s dot at 0, and that's if that's a 0,
Oh right? Yeah, you just treat it as each individual character.
So we just count like how many zeros and ones we got. Like this is actually gonna be a lot easier than I thought it would be. So we'll need like
true programmer moment.
Yeah, like and it's actually gonna be pretty easy. We'll have to convert it into a binary number at the end. 2 binary numbers, one for the most common, one for the least common. I think those are going to be like I think they're going to be like inverses of each other, right? So rather than the most, use the least. So if we had 0101, this one should be 10. Yes, these are inverses of each other. Okay. Yeah. Okay. So actually, could probably just compute one from the other, and then we have to convert it to from a string to decimal. Huh. You thought we'd have to use bool? Yeah. I think it's actually kind of nice that we just have it as a string, because we can just look at each individual digit. Okay, so I guess we can just make a count like vec. I don't think we need 2, honestly. I think we can actually do this just one vector. Sorry, vector of integers named vec, and then we'll have like int rows So every time we read something in, rows plus plus, see out rows. A rose by any other name is still a rose. And then this will just be, I guess we can just hard code it as 12, because all these things are 12 wide. And so, I don't know how much debugging I'm going to do on this, but we just do this. Okay, so for int I equals 0, const int size equals 12. I'll do it properly. Anytime a magic number appears twice, I'm not gonna be too sloppy there. Okay, so so we start at the left is 0 and the right. The right is okay, 11. Okay. So if s dot at I is equal to 1, then vector dot at I plus plus. So what we're doing here, it's a count of how many ones we've seen at this position. So we're going to count how many ones are going to be in the left column. Then the next vec.at1 is going to be how many ones have been in the one location. Then vec.at2 is going to be how many ones are in the 2 position, so on and so forth. So I think that's good. What do you guys think? I might need to make my own test file because this one's going to be too big. Like when I run this, I'm not going to know, like, is that correct? I don't know. You know what I mean? Like I don't know if this is right. And so
yeah,
so what I'm going to do is change input 3 to be just input, vim input, and I'm just going to delete all those, and vim main.cc. Okay, and so now we're just looking at the top 4 rows. Okay, so there are 2 ones in the left position, there are 4 ones in the second position. There's 3 here, 1 here, 2 here, 1 here, 4 here, 2 here, 2 here, and 0. Okay. And 4 is how many rows we've read. Okay, good. So good, it is working. Just returns account, and by returns you mean cout. Okay. So what do we do next? Where do we go from here? How do we tell if a bit is the most common bit versus the least common bit? There's only 2 options. The most common bit is either 1 or it's 0. How do we tell if it showed up in more than half of the rows? Rohan, what do you think? How can we tell if the left column here, or let's say column 1, which has 4 ones in it, how can we tell that the most common bit there is 1 versus 0? We've got a count, we've got how many rows we have. How do we tell if the count is greater than half the number? I don't know what happens if it's a tie. I wonder if they have an odd number to.
Well,
most common bit. See, it doesn't say what happens if there's a tie. Right? So, just out of curiosity, I bet they have an odd number in there. This is my guess. No, they have an even number. Okay. So,
okay.
What if we had 500, 500? We don't. So we don't have to worry about it. None of them are exactly split 50-50. Nice. Okay. If it's greater than rows divided by 2, yes, very good, very good, very good. Okay, so okay. how do I do this in a way that the CSI 40 students will get it? I can do it with bit shift and stuff.
I think C++ has something like bit sets or something. I don't
There
know.
is. String to decimal. Or if there's a. Aha. 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 Okay. All right. Okay. Case 2 conversion. All right. Sweet. We don't even have to write ourselves now. All right. And then they're doing a bit set with this. Okay, that's even easier. So bit set is the C++ way of doing it. Even easier. Okay, all right.
Yeah.
Sweet. Okay. So yeah, so I was gonna just do this conversion myself, but this is cool. What if it's the same? Yeah, exactly. It's not. I just checked. There are no ties. Okay. So we need to make a string that is made of. We're going to make 2 strings. So we're going to make the gamma string. We don't need rows anymore. Okay. So we're going to have a string called gamma, size 12, and we're going to make a string called epsilon, size 12. Does it not like that? No matching constructor. Yeah, that's fine. Okay, so 11 to the right. So I'm just going to make a string that's 12 zeros in each. And then what I'm going to do is I'm going to go over the count. And if the count is higher than, yeah, okay. So for n I equals 0, I is less than vector dot size, or you just do size, whatever. I plus plus. So if vector dot at I, that's the count, right? So if we had like 700 ones, then the most common bit is 1, and so gamma will get the 1. If it's less than 500, then epsilon gets the 1 instead. If vector dot at I is greater than rows divided by 2, then gamma dot at I equals 1. Else epsilon dot at I equals 1. So each time we find who the most common bit is, it either goes into gamma if ones are more common, or goes into epsilon if it's less common. And so basically you just parcel out the one to one or the other each time. I'm initializing them all to 0 for a reason. Okay, so okay, then we can just see out these 2 things and see where we're at. Gamma, let's see if we're just completely off base with this, but I'm 100% confident this is going to work right the first time, every time. 60% of the time. Okay. So what do we got here? We got 10. Oh. See, I don't know if these are correct anymore, but okay, let's look at the numbers. So that's the most common bit. That's less common, more common, less common, less common, more common, more common, less common, less common. Okay. I think it worked actually. I think it worked. So then we just need to convert those numbers to a number.
So wait, so is there an actual difference between using bit set and then using the tool there?
Which one?
Is there an actual difference with using that function and bit set?
They're gonna result in the same value.
Oh, okay, cool. Yeah.
Okay, let's find out if that's correct. Calculator, Windows calculator, switch into programmer mode. I choose you. No, that's decimal. Give me binary. No, clear everything. Clear everything. Paste. Okay, so this is decimal 2663. Good. The conversion worked properly. And then for you, paste, converted to decimal is 1432. Sweet. Okay. So the binary to decimal conversion was successful. And then our answer, cout answer, value 1 times value 2. And there we go. 361, 381. Okay, is that the product of the two things? It probably is. It seems about right. All right, see if we can go for 9 in a row on the Avena code. So, gamma rate, epsilon rate, multiply them together. What is the power consumption? Should represent in decimal, not binary. Okay, let's try that. It's the right answer. Ba-ba. All right, 9 for 9 so far. 9 for 9. Continue to part 2. Okay. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. But the oxygen generator rating and the CO2 scrubber rating are the values that can be found in your diagnostic report. Finding them is the tricky part. So the life support rating is the product. They like multiplying two numbers together. I guess that's so that you only have to enter one number, right? So we have to compute the oxygen generator rating and the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in this report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Okay? Considering just the first bit of those numbers. Then keep only numbers selected by the bit criteria for the type of rating value for which you are searching. What is the bit? What does that mean? Bit criteria. Keep only numbers selected by the bit criteria. Searching, discard numbers. Okay, I don't know what this means. Okay. If you only have one number left, stop. This is the rating value for which you're searching. Otherwise, repeat the process considering the next bit to the right. Okay, so what does this mean? Bit. Okay, there we go. Bit criteria depends on which type of rating value you want to find. To find the oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. Okay. says to consider just the first bit and keep only numbers selected. It's going to require refactoring, absolutely, but it's going to be the same input, right? So keep only numbers selected by the bit criteria for the type of rating value. Which you're searching. Discard numbers which do not match the bit criteria. Bit criteria. Okay, maybe I'm going to need to see an example on this. Okay. The bit criteria depends on which type of rating value you want to find. To find the oxygen generator rating, determine the most common value in the current bit position. Keep only numbers with that bit in that position. Okay. So if 0 and 1 are equally common, keep values of the 1. Yeah, thanks for telling us now. To find the CO2 scrubber rating, determine the least common value in the current bit position. Keep only numbers in that bit in that position. If 0 and 1 are equally common, keep values of the 0 in the position being considered. So this seems very similar to what we did before. So for each bit position, we keep only numbers with that bit in that position. So what's the difference here? Okay, so determine the oxygen. Start with all 12 numbers and consider only the first bit of each number. Okay. Since, okay, so there are more 1 bits than 0 bits. So only keep the 7 numbers with a 1 in the first position. Okay, all right. So start with all 12 numbers. Only consider the first bit. There are more 1 bits than 0 bits. So okay, I see. Okay. All right. Then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bit, so only keep the ones that have a 0. Okay. Oh, I see. Okay. All right. 4 numbers with a 0 in the second position. Okay. In the third position, 3 of the 4 numbers have a 1. Skip those. In the fourth position, 2 of the 3 have a 1. Fifth position, there are an equal number of 0s and 1s. So to find the oxygen generator rating, we keep the number with a 1 in that position. Since there's only 1 number left, stop. It is that, or 23. My lord. Okay. So you stop once you're down to 1 number. If there's a tie, you pick. I wonder if there's any duplicates. Like, are they all unique? Maybe. If there's a duplicate, though, you're never going to be able to get rid of them all. Right? Okay. Then determine the CO2 scrubber rating from the value from the example above. Okay, so you pick the fewer 1 each time. It's the same thing, same exact code, but different, I think. So 0 in that position. It's opposite on that one. And then you convert to decimal. Okay. Finally, to find the life support rating, you multiply the oxygen times the scrubber rating to get 230. Use the binary numbers in your diagnostic report to calculate the oxygen generator rating. CO2 scrubber rating, multiply them together. What is the life support rating of the submarine? Okay. Probably do this with the linked list. Hey, Carly, what do you think? Good linked list assignment. Start off by loading all these strings in from a file, and then
Oh no.
and then you're going to sort them, right? Like some of the linked list items are going to go into. It's almost a tree.
Oh, the perfect data structure.
Kind of sounds like it does kind of sound like a tree, but like,
Except all the stuff that you don't touch, like you just leave unsorted. So you're kind of, it's like a really funky binary sort.
binary search tree because
It's a really funky.
all the nodes they're not touching isn't sorted at all.
Yeah,
so
we just leave everybody that gets discarded. They just get discarded. So I think maybe a linked list is the right way of doing it because we don't need the tree structure. So
right.
CO2 is still going to be the opposite of oxygen. Yeah. So we can start off by loading all these values into a linked list because we're going to be deleting out of the middle of it. And deleting out of the middle is linked list territory. So we're going to run our code. We should be able to repurpose most of our code because our code right now is counting the most common bits, sort of, although we're doing it afterwards. So we can go over the entire linked list, find which bit is the most common, and then delete everybody else. We'll need to do this twice, though. Once for the most common, once for the least common, then multiply them together. Do it recursively. 1, 2. Do it recursively. We can do it with vector, and that wouldn't confuse the 40 students. Although recursion does confuse people. You're already confused? Yeah. Well, see, the thing is, like, you haven't learned linked lists, really. Maybe a little bit. You've seen a little bit, but, like, you haven't really learned them yet. And this would actually be a good assignment, actually. Like, Ben Crowley's here. I don't know if he is. It's barely in the Zywox. Yeah, it's kind of touched on a little bit. Because what we're going to do is we're going to go through it and then delete everybody that doesn't have, like, a 1 in the second position or whatever. And then we'll sweep over it again and delete everybody that doesn't have a 0 in the third position. Because our current code is counting. Oh no, we can't use the current count because it's for everything. The most common.
Ben Curley's here.
Is he here? Okay.
Yeah, I'm here.
Yeah. So what do you think? You think we should do this with just vectors, not confusing?
Yeah, we could do it with vectors. It would be good practice, as you said, to make this like a linked list assignment for 41.
You could do it. You could do it as a vector, and then like have this become a linked list. Because I think this is a there's not really much of a difference. But
think about it. This is more of a. This is actually a perfect kind of linked list problem.
Yeah, it is, but it can also be done with a vector. But
well,
if you
to all 3 of the students that stayed for this, no. We'll do it with vector. We'll do it recursion. We'll do it recursion style. All right. So void slender. Do const vector of the elements in this. Actually, gonna be like a vector of strings, really. And so instead of this, have I already backed it up? Gotta back it up because I'm about to start deleting stuff. Okay, so what we're gonna do is we're gonna pass a vector and it's gonna have all the strings in it. And it's gonna count, it's gonna do a count and find out who's the most popular kid on the block in the first bit position. And then it's going to throw away, it's going to make a new vector of everybody who has that bit. So we can do one pass to count, then another pass to create another vector, and then recursively call it. And when we're down to just one element, we just print it to the screen because we don't need to do anything else with it. So okay, so if vector dot size is equal to 0, then we have a problem. Exit error 42. We don't need to be on multiple lines because it should not happen. Okay, so you gotta be a vector. Okay. All right. Don't need you anymore. So what we're going to do is we're actually going to make a vector of strings. So we're actually going to preserve all the input. Strings, I guess. And then that, and then we don't need count. We don't need that anymore. I'm not deleting it because we're going to be doing something similar to it. So strings dot push. Yeah, sure, whatever. Strings dot push back. Don't need you anymore. 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 Okay. Okay. So we've got all that code, and then we'll just going to verify that we're reading the file properly. So what we're doing now, before, as we opened it, we processed it. Now we're actually going to be preserving all of the lines of the program into a vector of strings, top to the bottom. Looks like it is working. Run it again, look at the top. 011, 011, 011. Okay, looks good. Our code is reading in the file properly. And so I'm going to switch this over to input, regular input, because it'll be a lot easier to deal with. It's just 4 lines. Right. Okay. So yeah, all right. You can do that with vectors, but a lot more code. I don't know. We'll find out. So we're going to call Slenderman and pass in strings. And so then it's going to call it, we're going to pass to it a vector with all of the strings in it. And we're going to first count, the first thing we're going to do is count which bit is the most popular in position pause. And so like when we first call it, it's going to check the first position, and if the one there is the most popular one, then we're going to make a new vector with all the people that have that bit, and then recursively call Slenderman. Okay. Vector dot size 1. Cout vector dot out 0 and return. Half the answer, but okay. Or if position is greater than or equal to vector dot size, it might be, there might be -1 on there. I'd have to read the README again. So if we come to the end, then whatever answer we have left is going to be the right answer. Or if there's one person remaining, that's the right answer. Otherwise, when we get to the end of it, then that's the right answer as well. Okay, so step 1, we see which bit in the first position is the most popular. Step 2, we split the vector into ones that have it, ones that don't have it, and then recursively call. Okay, so now we're going to reuse this code here. We already have effect. Damn it. Count. So for every string in our vector, we are going to count its bits. So for every string we have in our vector, we're gonna if it has a 1 in the first position, we add a 1 to our count there, and then let's just see it out right now. Just make sure that's working. Okay, so two 1 bits in the first column, 4 1 bits in the second column, 3 1 bits in the third column, 1 bit in the fourth column, 2 1 4 2 2 1 3 0. Cool. All right, so again, we're just counting how many bits are in each column. That's phase 1, and then phase 2, we are going to make a new vector, which is bad. So I was saying we should be using a linked list, but we're going to be making a new vector every time, and then passing it to a recursive call to itself. Okay, so we'll have a vector of strings, strings named new guy that's empty, and then for every for every const string s in vec, if and so bool winner. So is it 1s we're looking for, or is it 0s we're looking for? Are 1s more common than 0s in that column? And so that's going to be actually. I don't have to care about the current position. Yeah. All right. So we don't actually have to loop it. Yeah, whatever. I can clean it up in post production. So if count.at position, so if we're on column 0, if the count is greater than vec.size divided by 2. Okay. So if we've got more 1s, like if we have 10 numbers and 7 of them had a 1 in the first column, then this would be true. If 3 of them did, then it would be false. So if the count of how many 1s we had in this position is greater than half, and I think for this one it's tied, right? So yes. Then what we're going to do is we're going to build a new vector of the people that have a 1 in that spot. For every string in there, if s.pos, s.at pos, so if we're starting off at 0, it's the first letter. If the first letter of the string equals, let's make this a little simpler. So if we had more 1s and 0s, then the winning character is 1. Otherwise, the winning character is 0. Using the power of the ternary operator. Let's make things a little simpler for us. So if the, ternary, boom, there it is. PhD level if statement right there. So, yeah. So who's the winning character? It seems easier than using Boolean. I don't know. Maybe I could be wrong. Seems easy. So if S has the winner in it, then it is a winner too. And new guy dot pushback. Yes. And then we will print out everything, I guess. So for every guy and new guy, I see it out, I guess. And we're not doing the recursive call yet because I want to make sure this code is correct. Sign-on-sign comparisons. Yeah, okay, run it. So we have 2 people with the 1s in the first column, and it is this guy, this guy. It's good to me. Vim input. Let's make one of these a 0 and run it again, and you'll see that 0 is now the most common, and it's right to me. Okay, it's working right. So we are now able to pick out all of the strings that have the most common bit in the column we're looking at. And if you guys are confused, then it takes more time to do it this way. I don't know. It doesn't take that much. It takes more time to explain it, I guess. Maybe. I don't know. Okay, so we got this working. So we'll see out all the things, and then we will recursively call, and we should be good at that point. So we will call Slenderman, and it's called Slenderman because we are slendering ourselves down. New guy passed in with pause +1. So if our current column we were looking at was 0, we're then going to move on to column 1, and then select all the people that have the most common bit there, and then we slender it down and then move on to the second column, and we keep doing that until either we hit an empty vector, which shouldn't happen, there should always be 1, and when you either hit one guy or you reach the very last bit, which might happen if there's a tie, I think. So let's try it. Turn off the signed unsigned warnings. There we go, because they don't matter for this. All right. All right. So on the first one, I don't know if this is correct then. No, it is correct. Okay. All right. So I think it's correct. Let's take a look at this. So here are our 4 candidates. In the first bit, 2 of them have a 1, and so we select those 2 guys. In the next column, 2 of them have a 1, and so we select both of them again, right? Because they both have the most common bit. We then move on to the next one, and again, they have that, and then they have that, and they have that, and then this guy, though, has a 1 in the place where there's a tie. So the question is, why are we not getting 5 of these outputs? We have a tie. So that is the answer? I don't know. At least for these 4. I mean, it's correct, but I don't feel comfortable that it's correct. So let's throw some more options in here. So here we got 5 people, 3 of which have 1s in the front. And we got 3 people, and then 3 of them have 1s in the front. And then here we have 3 people, 2 of which have 1s in the front. And so we select those two, and then it's like here, right? But I need to make another one.
Oh man.
And see what's going on here. Yeah. So we're here. We got 4 people with 1s in the front. And so it selects those out. Then these guys all have 1. Yeah, let's input. Yeah. So here, and then it filters out everybody who doesn't have a 1 here. And this guy filters out everybody who doesn't have a 1 here. And then this guy should get filtered out. We go down to here, and then it's just picking the first guy. So I think it's stopping when we have a size of 2. Oh, right. Yeah, that's wrong. So when you get to the end of the the size of the bit, not the size of the vector. That's our problem right there. Okay. There we go. It's better. Okay. So there, and then that guy gets filtered out. Then that guy gets filtered out. Then these 2 guys, there's a tie between you, and so the 0 gets discarded, and we got this guy as the winner. So I think I feel good about this one now. Okay. Again, we don't need to be computing this whole thing. That's a waste. So let's pull that out real fast and see if we get the same answer. We don't need to look at everybody. We just need to look at if s.at pos is equal to 1. Oh, didn't work. I is not declared. Yes. Oh, we don't need count. Count. Because we're only looking at one bit, so we don't actually have to look at all the bits and how common those are. We only have to look at the one we're currently looking at. And I don't know. If this worked, we'll get the exact same output that we just got. So I'm not going to clear the screen. I'm just going to scroll up. Okay, so new guys. Looks right. This guy filtered out the 2 zeros, then it filtered out this 0, then it filtered out this, filtered out that 0. Seems to work. Okay. So there we go. I'm not happy about this using vectors. Like I said, linked lists, just going through and deleting people out of it is going to be better than constantly allocating new memory over and over again. It's going to actually have a higher memory cost than linked list version, but it's only 1,000. Okay, so that's one of the numbers. And so if we just run this on input 3, there's a lot of stuff in there, and it's slowly filtering people down. Ones, this guy should be picked, and there we go. So there you go. That's our oxygen consumption, or whatever that was. Yeah, that's our oxygen rating. Now we just need to do the same thing for the. Oh, and we need to convert that to a number. So the answer is U. Uh, okay, so instead of printing out the bit field, which we already know, it's just going to convert it to a binary number. And there we go. And we need a new line, of course, on that. Okay. So the answer is 2526, which I will just double check really fast. Programmer mode, binary. 2526, good. All right. And then we'll just do the same thing for the what was the other one? CO2 scrubber. Okay. I'm going to do something bad. I'm not going to do this in code. I am going to do something bad. Not doing this in code. The answer is 1184. And I'm just going to multiply by hand. All right. So decimal of 1184 times 2526 is that. I could have copied and pasted all that code, but I usually do it by hand. Is there a tie? Wait, if there's a tie, then we're supposed to pick the 0. No, this is wrong. Right? No. Yes? No? Let's see. The winner to count. That's... Yeah. So, yeah, we're picking the least common person now. And if there's a tie, then it picks a 0. I'm gonna just go with this. All right. So 299,784, 299,784. We'll copy, and we will copy. Can I copy from you? Right, fine, I'll just type it. If this works, I'm gonna laugh. Diggity damn. 10 for 10. All right. Feels good. Feels good. All right. Number 10. 10 Pete. So I don't know if you guys saw that, but like the code for the oxygen scrubber and the CO2 scrubber are almost identical, right? It's just a matter of just changing that one to a 0 and 0 to a 1. And then I just wrote down the previous answer and reran it because it's like I'm not ever running this code again. You know? So fine, I'll do it properly. My lord. Bool, what is it called? Like Oxy content or something. True. There, you guys happy now? So if it's if we're doing the oxygen meter, it does it one way. If we're doing the CO2 scrubber, it's the other way. And we'll pass in here if we were oxy or not. And what's the matter with you? Why are you mad at me? Missing a default. And then down here, we will Slenderman strings 0 true. String 0 false. And supposed to multiply the numbers together, so we'll just do that. They're not currently returning anything. It is a void function, so we will return an integer, and we will return and I don't need this STDs anymore. Whatever, we're too cool for school. And you should also return this. Okay. And there's our answer, 299,074. That's the proper answer. You. Why did it not print the answer?
I'm gonna get going. I'm gonna need to take a nap.
Oh, we're done. We are done. Why is that not printing?
I'll see you guys later.
See you.
Bye bye.
Oh man.
It was like 299,074. Why is it not printing answer? Why is that not appearing? Oh, I know why. Yeah. It's recursive. There. Right. There we go. All right. There we go. Beautiful.
Nice.
And there we go. So move input 3 and add print 21. Remove my test. And that is the semester. So hope you guys had fun coming out, watching that.
Yeah, I did. Man, linked lists.
Yeah, I mean, it'd run faster, but there's only 1,000 people, so. And it might not even run faster. I mean, it's linked lists aren't necessarily
Depends on.
Yeah.
Oh, it depends too. Single linked list, maybe.
Well, the thing is, like, we have contiguous memory, and we're iterating across contiguous memory and copying to new contiguous memory, and so it's probably plenty fast. Java linked lists, rather, they are fragmented through memory. It's possible this is actually faster. It will use more memory because we're constantly copying all the entire vector into a new vector, into a new vector, into a new vector, into a new vector. So it's probably
and doing that recursively too.
Yeah, so it's probably gonna have a much higher memory impact, but with only 1,000 people, it's not enough for me to care. So we got the answer. That's all I care about.
Yeah, that's true. This is for more optimals, then you would definitely have to probably change it up and not use recursive.
It depends. If they're it's one of those things where you have to decide if it's something you're going to worry about, and in this case, it's just not something I'm going to worry about.
Yeah, because it's only 1,000 people, so it's not really going to matter in this case, unless if you're dealing with much larger data sets, then probably you would think about it.
If it's slow enough to annoy me, then I'll fix it. But
yeah,
sometimes it's true. Like, even if you're talking about like all the students at our college, right? It's like 10,000. It's like 10,000. Like it's doesn't matter, right? Like, there's just not enough students at our college to like stress anything. Unless you're doing like really intensive like work on each student. If you're just doing something like adding up all of their grades or something and averaging them, it's such a tiny number that it really doesn't matter. Okay, we got the ECM workshop at 6. I'll see you guys all there, and thanks for a great semester. See you guys next time. Peace.
Yeah.